And finally, we're looking at solving uh, logarithmic equations. There are different routes that you can take to solve different types of logarithmic equations. A key is when you have the same base, chances are what we're going to want to do is to get rid of everything except a logarithmic expression, a single logarithmic expression on each side, because when we have log base a of x equals log base a of y, we know that x equals y. In other words, log base a of x. So if log base a of x equals log base a of y, then we know x equals y. And again, different variables than what we have seen in the course. Doesn't matter what variables you use as long as you understand what it means. If you have log equals log, then whatever you're taking the log of is also equal. So how can we make, on this left hand, or on this right hand side, we have log base 3 of 36. So we can leave that alone for now. We already have log base 3 of one entity. On the left hand side, we have log base 2 times log base 3 of x. So we need to get rid of this 2 from in front of the log. How might we do that? We can use the power property. We transform this left-hand side to, that is log base 3 of x. We move the 2 to the exponent, x squared. That still equals log base 3 of 36. So now we have log base 3 of something equals log base 3 of something. So that means we can set the somethings equal to one another. So we know x squared equals 36. Taking the square root of both sides, we'll go ahead and leave the plus or minus for now. That means that x equals plus or minus 6. Well, log base 3 of negative 6. We're not going to be able to take anything to the power of something and have it be negative, and therefore x can't be negative. So we know that x equals 6. So 2 log base 3 of 6 equals log base 3 of 36. That means that x equals 6.